Section 7-2 is about similar polygons, which continues nicely from our last discussion about ratios and proportions, because similar polygons are proportional and they have some common ratios. Okay, so let's look at some similar polygons. Here I have two trapezoids, and they're similar. That's what this symbol right here means. It's like the congruent symbol, but not being equal. Okay, so trapezoid ABCD is similar to trapezoid GHIJ. Okay, what that means is the corresponding angles are congruent. So angle A and G are congruent, angles B and H are congruent, angle C and I are congruent, angle D and J are congruent. Okay, but not only that, the corresponding sides are proportional, not congruent, but proportional. So if I look at AB over GH, that ratio is the same as BC over HI, which would be the same as the ratio of CD to IJ, which is the same as AD to GJ. Okay, let me give you some numbers just to show you what that looks like. If this length was 4, and this was 5, and this was also 5, and this was 7, and this was 8, and this was 10, and this was 10, and this was 14, then the ratio of AB to GH would be 4 to 8. And that would be the same as BC to HI, or 5 to 10. Okay, CD to IJ is also 5 to 10. And AD to GJ is 7 to 14. Okay, so all these ratios are equal to 1/2. Okay, and 1/2 is an important number. It's called the scale factor. We'll get into that a little bit later. But the corresponding angles are congruent and the corresponding sides are proportional. So let's take this one and find the congruent angles and the extended proportion for the sides. So you can look at either this similarity statement or the picture. I tend to look at the statement because I think it's faster and easier, but you can look at the picture if that helps you. Angle A is congruent to angle W. Angle B is congruent to angle X. I'm looking just in the order. Angle C is congruent to angle Y, and angle D is congruent to angle Z. Now, the corresponding sides. AB divided by WX is equal to BC over XY, and CD over YZ is equal to DA over ZW. Okay, now this is an extended proportion. It's a proportion with 3 or more ratios. Okay, but we found the corresponding angles that are congruent and the corresponding sides that are proportional. Okay, are these polygons similar? Okay, and if they are, write a similarity statement and give the scale factor. Now looking at these two rectangles, it's pretty clear that the ratio of, if I thought of these as corresponding sides, it wouldn't work because 15 and 15 are the same and 10 and 20 are different. But if I thought about taking this one and turning it on its side, so I think about 15 to 20 as corresponding sides and 10 to 15 as corresponding sides, that might work. So I'll look at the ratio of 15 to 20, and I'll compare that to 10 to 15. Now 15 over 20 is 0.75, and is that equal to 10 over 15, which is 0.66? Well, no, they're not the same. And so these two rectangles are not similar. Okay? Even though they have congruent corresponding angles, their sides are not proportional. Let's look at B. I'll just take 18 to 9 and compare that to 12 to 6. Well, 18 over 9 is 2, and 12 over 6 is 2, and so they are equal. Okay? And the number is 2. So we'll look at that number. 18 over 9 is 2, 18 over 9 is 2, and 12 over 6 is 2. Okay, so they all have the same ratio, okay, the same scale factor, and so these two pentagons are similar. So my similarity statement is A, B, C, D, E is similar to, make sure the order is the same, S, R, V, U, T. And the scale factor is 2. Okay, and that'll wrap up our first video on what does it mean for polygons to be similar.